right, here to help out with ratios, rates, and proportional relationships. While I am gone on the Big Money Expedition, this will be a very helpful video for you to watch and to maybe review to help finish this worksheet that you'll be working on while I am gone. I will have another video for your lesson next class, so make sure that you're watching all the Edpuzzle videos, because especially in this crazy 2 weeks to where we're going to have people going at different times, it'll be very important that you are making sure that you get that you watch those videos so that you understand what we're supposed to be doing, because we'll be at different spots with the kind of the checklist of things that I want you working through. So looking at ratios first. And so ratios are a comparison of two numbers. So it's a comparison of two quantities. So if they can be written three different ways. So 2 to 3, 2 to 3, or 2 to 3 is how we say all of them. But again, this one has the word actually 2 in it. This one is written as a fraction. And this one is written using colons. So I'm going to work through a couple problems here. Okay. In no way does that mean that you are not then completing the rest of the problems. Okay, just because I do part of it here, that should mean that I'm helping you kind of figure out the rest of the problem later on. And so if we look at an example, okay, of writing in a ratio, so in a 7-game series, baseball team won 4 games and lost 3. Compare the number of wins to the number of losses. So if I were to write a ratio, okay, in, let's say, fraction form, it would be 4 wins to 3 losses. Okay, if I would have write in a colon for it, it'd be 4 wins to 3 losses. So again, it's a comparison of two different quantities, two different numbers. So we're comparing the 4 wins to the 3 losses. So I'll have you could then finish this part off, because there's one more that is missing here. Then also comparing the number of wins to the total number of games played, which that information is also given up here. Okay, looking at equivalent ratios, we've talked about this in a do now before, to where you are. It's just like an equivalent fraction. So you can multiply or divide both the numerator and denominator, or the first number and the second number, by the same number. It ain't going to be any number. So you can multiply by 2 here to get an equivalent one. So it'd be 4 dogs to 6 cats. Or you can multiply by 50 on each of these. Okay, and get an equivalent fraction. This is also one that you could divide both by the same number. So you're just rewriting, and there are infinite number of answers that you could have for these, but you're just writing equivalent ratios to each of these, so that we better understand what a proportional relationship is. And when we have two equivalent ratios, that's called a proportion, and we'll be talking about that next class. If I look at unit rates, we've talked about this briefly as well, but unit rate is it's a rate, which is a type of a ratio, but the denominator is always going to be 1. So this is 15 miles per 1 hour in all forms. Okay, written. You notice MPH isn't on here. This would be the correct way to show that. So looking at this, okay, whenever, like on this problem here, it's telling you what order you should kind of divide. And it's because if we're given inches and we're given hours, we're going to be doing inches divided by hours. So here, to find your unit rate, which is going to be inches per hour, you would do the number of inches divided by the number of hours. On problems like this, okay, you need to make sure that you know kind of what your measurement is in one form of that measurement. So what I mean by that is that you're converting 2 minutes and 30 seconds to either all minutes or all seconds. So an example would be like if I have, let's go through this. If I have 3 minutes and 10 seconds. Okay, I'd have to convert 3 minutes and 10 seconds to either all minutes, which minutes would be, okay, there are 60 seconds in a minute, so 3 multiplied by 60. To find that, okay, in the 3 minutes part, there are 180 seconds here, plus the 10 seconds. Or sorry, I'm converting this to seconds right now. My apologies. So in seconds, okay, 3 multiplied by 60 to find the number of seconds, which is 180 seconds, plus the 10 seconds here, and that'd be 190 seconds. Then if I wanted to convert this to minutes, okay, it would be, here we go. It'd be like saying, all right, 10 seconds would be, how much of uh, a minute? So 10 divided by 60, and that is 1.6. So it'd be 3.16 repeating actually minutes. Okay, this one's a little bit easier than that example because it's just 30 seconds, which 30 seconds is only half a minute, or 0.5. So then again, I give you this here because anytime you're looking for average speed, it's distance over time. So you have a distance, you have time, and you're asking to find the average rate or the speed, or the distance divided by time. If we then look at some of these other, so here I have a number of different unit rate problems. Talking about proportional relationships. So proportional relationships, kind of going down here. Proportional relationship is two quantities are proportional if they have a constant ratio or unit rate, also known as a constant of proportionality. So I'm going to show you an example of that rather than kind of going over one of these. But on these, again, you're graphing this. So this one I have you actually make the grid. So again, make sure you're going up by the same number each time. This one's a little bit easier than we had done with our walking activity, but make sure that each of these spaces is worth the same. So you can go up by 10 each time, you can go up by 20 each time, but you can't go up by different numbers each time. So then if we look down here, okay, you'll see some numerous kind of examples like this, and where you have to graph them as well and talk about them and then compare graphs. This one, I gave you a situation, and you got to use that situation to answer. Okay, if they after 4 hours they've gone 220 miles, okay, 4 hours, and after 5 hours they've gone 275. You're trying to fill out the rest of the table here. Okay, so you fill in the missing values. Okay, you're trying to write an equation for that, which I'll talk about below, and then also graphing. So if we look at this, okay, trying to determine if something is proportional or not proportional, okay, on a table, okay, I'm looking at what can I do to x to get to y every single time, or you're thinking y divided by x every single time, and what do I get? So it's the same thought process, but if I do 5 over 1, 5 divided by 1 is 5. If I do 10 divided by 2, I get 5. If I do 15 divided by 3, I get 5. If I do 20 divided by 4, I get 5. So notice I get the same number every single time. So that means that this is a proportional relationship. So this is proportional, okay, because because of this, I know I can also, whatever I have for x, I can just multiply it by 5 to get y. So 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15, 4 times 5 is 20. So this is proportional. The unit rate, aka the constant, if I could spell it right, constant of proportionality, here would be equal to 5. Okay, so that's your constant of proportionality, which it's what is y divided by x, or again thinking what am I multiplying x by to get y. So other things here that you'll have to do with this is write an equation, write in a rule, which is just saying, okay, like I just said, what am I doing to x? So what am I doing to x to get y? So this is how we would write our equation of, okay, am I adding something to x? Am I multiplying something by x? Am I dividing x by something? Am I subtracting something from x to get equal to y? Well, like I just discussed, we are multiplying each of these by 5. So 5 multiplied by x would be our equation, all right, or aka our rule. So that would be our equation that we could write for this. And again, notice 5 is there and there. And then other thing with this would be graphing. Okay, so graphing this, okay, we'd have our y and our x-axis. Okay, 0 would be here. Okay, and I could set this up to where, okay, here's 5, 10, 15, or no, sorry, 1, 2, 3, 4. So this is 1, 2, 3, 4. Almost made the mistake there. But x's go on the x-axis, y's would go up here. So this would be 5, 10, 15, and 20. And so plotting the points here, okay, I plot, okay, 1, 5, I go 1 to the right, up 5. 2, 10, I go 2 right, up 10. 3, 4, I go to the right 3. Not gonna be perfect here because my scale isn't drawn great. And then 4, 20, I go to the right 4 and then up 20. And notice, whoa, that's a bad line. Where's my eraser? There it is. Trying to erase this. But notice that a straight line is formed. Let's see if I can do that this time. As straight as I can. Okay, so a straight line is formed here in which, okay, it also goes through the origin. So I had you already watching that puzzle on this. Okay, so the origin is the point 0, 0. So where this graph begins. So on a graph, if it goes through the origin, the point 0, 0, and is a straight line, it is always a proportional relationship. If it does not go through the origin, so let's say it starts up here and it's a straight line, it's not proportional. Okay, and there's many other different examples of non-proportional relationships, but proportional relationships are always going to start at 0, 0 and be a straight line. So if you have questions, please make sure that you ask the sub, but also you can email me and I will see you again soon to help out with any questions. Thanks.